All right, today we are going to review for your Conceptual Unit 7 test. All right, number 1, it says the graph of an exponential function is given to the right. Select the function for the graph from the following options. Well, obviously they're saying whatever the answer is, its base is 5. So the mother function would be y equals 5 to the x, which passes through 0, 1, and 1, 5. So if I plotted that, 0, 1, 1, 5, 2, 3, 4, 5, there's what 5 to the x would look like. Okay, so I have to figure out what they did. Well, if the answer is negative 5 to the x, then, which it is, obviously, the star is there. If that is the answer, then what that would do is change the sign of y's. So 0, negative 1, and 1, negative 5. Yeah, change the sign of y's. So if I plotted those points, 0, negative 1, 1, negative 5, 2, 3, 4, 5, then this would look like this, which is what that looks like. 0, negative 1, 1, negative 5. That's exactly what it is. So it's got to be the negative. I assumed it was that one, not just because it was first, but because this was flipped upside down. And to reflect over x, you've got to multiply y's by a negative, which means it's got to be outside or on the ground, not with the x. Okay, this would have just shifted it to the right one. It wouldn't have flipped it over. This would have flipped it over. This would have been over x, but it also would have been over y, which means then it would turn around and it would do, instead of this, it would do this. Okay, so it can't be that one. If it was this one, it would be mother, which is the original one I graphed. This would be 1 unit down, so it would look like that if it was that one. And this would just be reflected over y, which would look like that. So it's got to be the reflection over y. All right, it says use transformations of the graph of f of x equals 3 to the x to graph the function g of x given below. Graph and give the equation of the asymptote. Use the graph to determine the domain and range of g of x. Okay, well, if we were doing this by hand and not on the computer, you would get your points for mother. Mother would be y equals 3 to the x, which passes through 0, 1, and 1, 3. And this says subtract 2 from the y. So minus 2, 0, negative 1, 1, 1. So I would plot those. 0, negative 1, 1, 1, and that would be the new graph. On Math Excel, when you click this, or you pick the, I wish I would have made a picture of that. You pick the exponential function tool, you click it anywhere it goes in, then this box is going to show up and it's going to ask you for vertical, shrink or stretch, horizontal, shrink or stretch, vertical, shift, horizontal, shift, reflect over x, reflect over y. And then I think down here it says what the base is, but it automatically puts that in. Your base would be 3 here. All right, so vertical shifts stretches or shrinks. These two up here are when you are multiplying. If it's a vertical stretch or shrink, then it'll be a negative touching whatever base it was, which that didn't happen. So this stays 1. It's not going to vertically stretch. Horizontal stretches or shrinks would be not a negative there, but something like maybe 2 times something, or 3 times something, or 4 times something. If there was something being multiplied by that 3 to the x, that would be your vertical stretch or shrink, but there's nothing there. To have a horizontal stretch or shrink, you'd have to be multiplying x by something like 2x, or 3x, or 5x, or 12x. But there's nothing touching x, so there's no horizontal stretch or shrink. That stays 1. Your vertical shifts are when you're adding or subtracting on the outside, on the ground, like plus 5 or minus 7. Okay, they are subtracting 2 to it. Okay, minus 3 to the x, minus 2 on the ground. So that's going to be a vertical shift of negative 2 because it's going to move it 2 down. And in order for there to be a horizontal shift, there'd have to be something added or subtracted up here, and there's not, so this stays 0. Now, for reflections, you look for negatives touching the 3 or the x. If there was a negative out here, you would check the box reflect over x, but there's not. If there was a negative touching x, you'd check this box, but there's not, so you don't check either one. Okay? Which, once you plug in just that information, then just that -2 right there, it will automatically move the exponential to fit those transformations that you told it. And then you have to do the asymptote. Well, the asymptote is always going to be, then you'd have to, from that box, you'd pick the dotted line or the line function, the line tool, and you could put, it's right there at the bottom of the thing. So you could pick a point there and then move the second point there, and then make sure you select dotted, and that will be your asymptote. So for the equation of the horizontal asymptote, remember your horizontal asymptote for all exponentials is y equals 0. And it only changes if you shift this thing up or down. So since we shifted down 2 units, instead of it y equals 0, it's y equal -2. For exponentials, the domain is always -infinity to infinity. And range is usually 0 to infinity unless you shift it up or down. And I shifted down, so that 0 turns into -2. Alright? Number 3, it says use the compound interest formulas A per naught and A per to solve the problem given. Round answers to the nearest cent. It says find the accumulated value of an investment of $15,000 for 4 years at an interest rate of 7% if the money is A, compounded semi-annually. That would mean I'm using A per naught. 1 plus R over N to the NT. And B, compounded quarterly. Again, I'd be using A per naught. And compounded monthly, A per naught. To the NT, sorry. And then compounded continuously, that one we'll use A per for. Alright. So, to figure this out, let's see. Let's write down our information somewhere. I need an A, I need a P, I need an R, and I need an N. A is the amount accumulated, so that's my I don't know. The principal amount, you're investing $15,000 for 4 years at an interest rate of 7%, and then we're ready to go. Okay, so if it is compounded, not N is not 4, T, time, my bad, time is 4. N is going to vary depending on what problem we're doing. For A, N will be 2. For B, N will be 4, quarterly. For C, N will be 12. And for D, you don't need an N. Okay, so if I do A, I'm going to have A equals my 15,000, 1 plus, my rate is 0.07. For A, my N is 2, to the 2 times 4. So if I type that in very carefully, 15,000, parentheses, 1 plus 0.07 divided by 2, parentheses, caret 8, hit enter, and you get 19,752.13555555. If I round to the nearest cent, that's going to bump it up to a 4. For B, A equals 15,000, 1 plus 0.07. The only thing that's changing is my N, so N would be 4, to the 4 times T, which would be 16. So if I type that in, 1,500 times, parentheses, 1 plus 0.07 divided by 4, close the parentheses, caret 16, and I get the 19,798.9. Oh. Oh. I actually got 1979.894. I don't know where they got that from because I didn't round anything. 0.07 divided by 4, caret 16. Oh, I forgot a 0. 15,000, parentheses, 1 plus 0.07 divided by 4, close the parentheses, caret 16. There we go. 0.94027. So if I round to the nearest cent, the 4 doesn't change. Watch your typing, even I did it. Alright, for C, we'll have the amount is 15,000. 1 plus 0.07 divided by 12 to the 12 times 4. So 15, 1, 2, 3, parentheses, 1 plus 0.07 divided by 12, close the parentheses, caret 48, and I get 19830.808. That 8 will bump that up to a 1. And then for A pert, you have A equals the principal, 15,000, E to the rate, 0.07, times T, which was 4 years. So if I type that in, 15,000, second E, divide for E, caret, parentheses, 0.07 times 4, close the parentheses, and I get the 19,846.95. Yeah. Okay, so which is the better deal? Compounding continuously, if nothing else, if other variables stay the same. Alright, it says the 1984 explosion at the nuclear lab sent out 1,000 kilograms of a radioactive element into the atmosphere. The function f of x equals 1,000 times 0.5 to the x over 30 describes the amount f of x in kilograms of a radioactive element remaining in the area x years after 1984. If even 100 kilograms of the radioactive element remains in the atmosphere, the area is considered unsafe for human habitation. Find f of 80 and determine if the area will be safe for human habitation by 2064. Alright, and the reason they're saying find f of 80 is because x stands for the years after 1984. So if I'm trying to figure out how many years after 1984 2064 is, I subtract and I get 80, which is why we're finding f of 80. So that would be 1,000 times 0.5 to the 80 over 30. So if I type that in, I have 1,000 parentheses 0.5 parentheses caret parentheses 80 divided by 30 parentheses, and I get 157.49. So no, it's not going to be safe because there's more than 100 kilograms left, which means it's still unsafe for human habitation. Alright. The formulas S equals C times 1 plus R to the T models inflation, where C is the value today, R is the annual inflation rate, S is the inflated value T years from now, and T is time. If the inflation rate is 7%, how much will a house now worth $122,000 be worth in 5 years? Round your answer to the nearest dollar. So it says C is the value today, and that would be my 122,000. T would be 5, and R would be 0.07. So if I plug those in, S equals 122,000 times 1 plus my rate, 0.07, to the time, which is 5 years. So if I type that in, 122,000, parentheses, 1.07, parentheses, caret 5, I get 17111.3111. and they want us to round to the nearest dollar. That won't bump it up, so my answer is 171,111. Okay. Alright, it says the graph shows the number of words in millions in a particular government document for selected years from 1955 through 2005. The data can be modeled by either this function, which is linear, or this function, which is exponential, in which f of x and g of x represent the number of words in millions in a document x years after 1955. Use these functions to complete parts A through C below. A. According to the linear model, how many millions of words were in the government document in 1995? So they're telling me to use the linear model, which is f of x. And it's telling me the time is 1965. So x represents the number of years after 1955. So 1955, 1995, take away, that would be 0, that would be 40 years. So they're telling me to replace x with 40, which would give me 0.17 times 40 plus 1.86. Type that in, 0.17 times 40, enter, plus 1.86, and you get 8.66. Okay? So if I round it to the nearest to one decimal place, that would bump it to 8.7. According to the exponential model, so now we're using g of x, how many millions of words were in the government document in 1995? So still we have the 40 years, so we're finding g of 40, which would be 2.11 e to the 0.0396 times 40. So if I type that in very carefully, 2.11 e caret parentheses 0.0396 times 40, close the parentheses, enter, you get 10.285 to the nearest tenth would be 10.3. Okay, then it says which function is a better model for the data. Well, if you look at 1995, the actual answer was 8.4, which is closer to the linear answer than it is the exponential answer, so the linear model would be the better one. Okay? Alright, write in logarithmic form. Okay, to write in logarithmic form, you put the base back under the log. So there's your base. It's got to go back to the other side under his log, and everything else will drop. So I have log base 4 of 1/16 equals -2. Okay, write the following equation in its equivalent logarithmic form. Again, the base goes to the other side, crawls under his rock. The x drops on this side, the 2 drops on this side, and you are in logarithmic form. Be careful not to solve these. Alright, a lot of people go, oh, so x is 121. Yeah, you're correct, but they didn't ask you to solve it. They asked you to write it in logarithmic form. Alright, so this one says evaluate the expression without using a calculator. When they say without using a calculator, they're telling you to make these guys match. So I need to break 256 down by 2's. 256 divided by 2 is 128, divided by 2 is 64, divided by 2 is 32, divided by 2 is 16, by 2 is 8, by 2 is 4, by 2 is 2. So I can rewrite 256 as 2 to the 1, 2, 3, 4, 5, 6, 7, 8. Now these cancel, and my answer is 8. Okay, evaluate the expression without using a calculator. Again, the trick is to rewrite this using 4's and get out of the denominator. So if I divide by 4's, 256 divided by 4 is 64. By 4 again is 16. By 4 again is 4. So I can rewrite 256 as 4 to the 4th. Yeah. Then I can move it upstairs, so that would be log base 4 of 4 to the -4th. And now they match, so my answer is -4. Okay, evaluate the following expression without using a calculator. Get out of the radical, which would be 9 to the 1/2. Because the square root of 9 to the first is 9 to the 1/2, innie over outie. These cancel, and my answer is 1/2. Okay, any log of 1 is 0. You should not even have to think about that. Okay, it says graph 4 to the x and log base 4 of x. These are inverses. I mean, I can do it mathematically. 4 to the x is going to pass through 0, 1, and 1, 4. So log base 4 of x is going to pass through 1, 0, and 4, 1. 1, 0, and 4, 1. It's got to be this one. Plus, guys, the only one that mother either splits in half or intersects when they intersect is this one. Okay? Well, I guess that one kind of does, but that one's facing the wrong way. Alright. Again, these are going to be inverses. Well, the easiest way to tell is look at what mother does. And right there, they intersect, she intersects where they intersect, so it's got to be D. Alright, begin by graphing log base 4 of x, then use transformations of this graph to graph the given function. So this one is a logarithm, so in that box, instead of picking the one that does this, which would be exponential, you pick the one that does this, which would be logarithm. So you plot this and you click it in the graph and it'll put it, I think, in standard position. It'll put it right there. Then the other little box pops up and it asks you again for your vertical stretches or shrinks, your horizontal stretches or shrinks, then your vertical shift and your horizontal shift, and then you reflect over x and you reflect over y. Okay? So what you do is this one is going to, again, if you're looking for stretches or shrinks, for vertical, are they multiplying the log by anything? Is that 4 times the log or 10 times the log? No, so that stays 1. Are they multiplying the x? Like, is it 2x or 5x? No, they are not. So the horizontal stretch or shrink isn't going to change. Your vertical shift is if they add or subtract something on the outside of parentheses. There's nothing added or subtracted outside, so that stays 0. Inside, they are telling me to add 6 to x, which means my horizontal shift is -6. There's no negative in front, so that don't check the reflect over x box, and there's no negative on x, so don't check the reflect y box. And it'll plot it for you. Now, on logarithm graphs, compared to exponential graphs, exponentials have a horizontal asymptote. Logarithms have a vertical asymptote. Okay, and since I moved 6 over to the left, it's going to be x equals -6. And you'd have to draw that as well. You'd pick the little line tool and select 2 points, any 2 points, and it'll draw that asymptote for you. Okay, for logarithms, the range and range and range and range will never, ever, ever, ever be different than -infinity to infinity. The domain changes when you move it right or left, and I moved it left, so you can see that my domain starts at -6, doesn't include it, and goes all the way to infinity. Alright, find the domain of this function. Hold on just a second. Okay. Alright, so to find the domain of the function, you basically take whatever's inside the parentheses and you tell it that it has to stay positive. So it's got to stay greater than 0. Which, if I subtract 1, then I say x has to stay greater than -1. So if there's -1, x can't include it, but it can be greater than, then my domain starts at -1 and goes to infinity. Okay, find the domain of this one. Well, I have 10 minus x that has to stay greater than 0. So minus 10 minus 10. Negative x has to stay greater than negative 10. Divide by negative 1. X has to be less than 10 because when you divide by a negative, your inequality flips. So if this is 10, I can't include it, but x can be anything smaller. So the domain starts at negative infinity and goes to 10, but doesn't include it. Okay? Write the equation in its equivalent exponential form and then solve for x. To write it in exponential form means roll the log and move the bug. When the log rolls over, the bug squirts over, so I have x minus 3 equals 4 squared. And they put it that way, but it's the same thing. Okay? And now to solve it, I have x minus 3 equals 16, add 3, and x equals 19. Okay, the loudness level of a sound D in decibels is given by the formula D equals 10 times the log of 10 to the 12th I, where I is the intensity of the sound in watts per meter squared. Decibel levels range from 0, which is barely audible, you can barely hear that, to 160, a sound resulting in a ruptured eardrum. The sound of a certain animal can be heard 500 miles away, reaching an intensity of 9.2 times 10 to the 8 watts per meter squared. That's I. That's this I over here. That's what they gave me for I. It says, determine the decibel level of this sound. At close range, can the sound of this animal rupture the human eardrum? So they're telling me to change I to 9.2 times 10 to the 8. So D equals 10 times the log of 10 to the 12th times 9.2 times 10 to the 8. Okay? So, let's see. This would be, if I type in 9.2 times 10 to the 8, and I multiply that by 10 to the 12th, I get 9.2 E20. Okay, so now I can use a calculator because this is log base 10 and log base 10 understands that. So if I do log of my answer, I get 10 times, this right here becomes 20.96378783. Multiply that by 10 and you get 209.6378783. It says round to the nearest whole number, so 6 bumps that up to a 10. So that's where they got the 210. And since that's more than 160 that can rupture an eardrum, yes, that animal could rupture a human eardrum. Okay? Graph f and g in the same viewing angle, then describe the relationship of the graph of g to the graph of f. Alright, well, log base 10 of x is going to pass through 1, 0, and 10, 1. 1, 0, and base 1. So, 1, 0, 10, 1. That's out here somewhere. Okay, so there's the right mother. Looks like there's the right mother. Looks like there's the right mother. Oh, they all have the right mother. Okay, so there's the right mother. This one is going to move it 2 units to the right. And this is going to move it 2 units down. Down 2, right 2. So there's the description. Now to get the graph, well, if I take these points and I mean, you can probably just tell by looking. You need to take mother and go down 2 and right 2. Well, this one went up, so it's not that. This would be mother, down 2, right 2. No. Down 2, right 2. Maybe. down to right 2, maybe. So it's between B and D. So I need to get some clearer points. So if I take my mother points, 1, 0, 10, 1, and if I do x first, that says add 2 to the x's, which gives me 3, 0, and 12, 1. And the minus 2 says take 2 away from the y's. That's 3, negative 2, 12, negative 1. So if I plot that, you can't read that, but 1, 2, 3, 1, 2, and 12, 1. Again, that one's not on here. But if I look at this one, 1, 2, 3, down 2. Oh, it hits at 2. But do you see how this one went to the left and it's actually supposed to go to the right? So even though that point's on there, I can still see that they shifted this one left. And I need to shift it to the right. So it needs to go this way. So it's got to be B. Alright, solve the following exponential equation by expressing each side as a power of the same base and then equaling exponents. We're using the formula that if I can get the bases the same, then I can claim that the exponents have to be equivalent. So the first thing is to rewrite 27, break it down by 3's. By 3 is 9, by 3 is 3. So I have 3 to the x minus 7 equals 1 over 3 cubed. And if I can move it upstairs, my bases will match. I can move it upstairs, which turns my positive 3 into a negative 3. And now that my bases match, I can write an equation with the exponents, which says x minus 7 equals negative 3. So add 7, and x equals 4. Yeah? Alright, so if we look at this one, I can rewrite 16 using 4 squared. Yeah? That's still 16. So now I'm going to power my power, which would give me 4 to the 2x minus 10. Because when you multiply exponent, when you power at a power, you multiply exponents, and this side is 4 to the x plus 8. Now that my bases match, I can say that my exponents have to be equivalent. So once I do that, I can get x alone, minus x, 8 equals x minus 10, add 10, x equals 18. Alright. Give me just a second again. Okay, sorry, I keep having little coughing fits. Okay, solve the following exponential equation by expressing each side as a power of the same base and then equaling exponents, so the directions are still the same. My bases almost match if I could just move e up, which I can by changing the sign of his exponent. So I'd have e to the x plus 9 equals e to the negative first, which means x plus 9 has to equal negative 1. Subtract 9, x has to equal negative 10. Okay? It says solve the exponential equation. Express the solution set in terms of natural logarithms. Then use a calculator to obtain a decimal approximation correct to 2 decimal places for the solution. So I have to isolate. I need to be able to drop it like it's hot, but I can't do that until I get e to whatever alone. So the first thing I have to do is add 2, and I get e to the 6x minus 5 equals 2, 2, 4, 3, 2. Okay, so now I can ln both sides. And ln basically cancels, which drops 6x minus 5 equals, they want the solution in terms of natural logarithms, so we don't actually want to type this in the calculator yet. So that's going to be ln of 22,432. So now to get x alone, I would add 5. So I get 6x equals, you can't add a whole number to a natural log until you figured out the natural log, so I just write plus 5 and then divide by 6. So in terms of natural logs, my answer is the natural log of 22,432 plus 5 over 6. That's where they get this. Now, to get the decimal, then you type it in the calculator. You type ln 22432, enter, or close your parentheses, plus 5, enter, divided by 6, enter, and you get 2.5030400632 to 2 places, leaves it 2.50. Alright. Solve the exponential equation, express the solution in terms of logarithms, then use a calculator to obtain a decimal approximation for the solution. There's no way I can make those bases match, because I can't break down 5s by 3, and I can't break down 3s by 5s. So I got to get x out of the air, and if you can't get it out of the air by making the bases match, then you have to throw a log at both sides. Oh, they're throwing a natural log. So I'm going to ln both sides again. Now I can drop it like it's hot. Drop it like it's hot. So now I have 3x plus 1 times ln 5 equals x plus 1 times ln 3. Okay. And so now, let's see, what do I want to do? I'm trying to figure out how they got to all this mess. Well, let's see. I'm trying to figure out how they got there. If I distribute, I'd have ln of 5 times 3x plus ln of 5 equals ln of 3 times x plus ln of 3. So let's see if I can get everything with an x on the same side. So I'm going to minus ln 3 times x minus ln 3 times x. I get ln 5 times 3x minus ln 3 times x equals ln plus ln 5 equals ln 3. So now, let's see. If I minus ln 5, I'll get ln of 5 times 3x minus ln 3 times x equals ln 3 minus ln 5. If I pull an x out of both of these sides, I would have 3 times ln 5 left minus ln 3 equals ln 3 minus ln 5. There we go. So now to get x alone, I'm going to divide by 3 times ln 5 minus ln 3. Divide by 3 ln 5 minus ln 3. And there's where they got that answer. So now to solve it, I type in ln 3 minus ln 5, either in parentheses or hit enter, over 3 ln 5 minus ln 3. Yeah? So, if I type that in, I'm going to do parentheses ln 3 close the parentheses around the around the 3, minus ln 5, close the parentheses, close the numerator, divided by 3 times ln of 5. We need a parentheses, second insert parentheses, ln of 5 minus ln of 3, and I get a negative 0.1369615319 to 2 decimal places. So that 6 bumps that 3 up to a 4. Okay? Alright, this is the one where this exponent is half of this exponent. So I can use quadratic techniques. And I'm going to try and factor because A is 1, B is 15, C is 14. Instead of putting x in there, I put e to the x, and the factors of 14 that make 15 are 14 and 1. C is positive, so they both get the middle. So now when I solve this, I have e to the x minus 14 equals 0, and e to the x minus 1 equals 0. This would give me e to the x equals 14, and this would give me e to the x equals 1. I've got to ln both sides to get rid of e. So here x equals ln 14, and here ln both sides, x equals any log of 1 is 0. So there's their answers without, not 0, x equals ln, no, well it equals ln of 1, but any log of 1 is 0, sorry. So there's my 2 solutions. And then if I turn this one into a decimal, ln of 14, I get 2.63905, blah, 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 which is the 2.64 and the 0. Okay? Alright, solve the following logarithmic equation. Be sure to reject any value of x that is not in the domain of the original logarithmic expression. Give the exact answer. Alright, so if I roll the log, the 4 shoots over, so I have x minus 2 equals 4 to the negative second. 4 to the negative second is 1 over 4 squared. 1 over 4 squared is 1 over 16. Add 2. I get x equals 1 over 16 plus 2. Get a common denominator, or use a calculator. So times 16 times 16. That would become, what is that, 32 over 16. Plus 1 would give me 33 over 16. So x equals 33 over 16. Alright, solve the logarithmic equation. Be sure to reject any value of x that is not in the domain of the original logarithmic expression. Alright, before I can roll the natural log, I've got to isolate it. So I'm going to divide by 3. That gives me ln of 4x equals 3. Now I can roll the natural log, which will move the base over. So I have 4x equals e to the third. And to get x alone, I'm going to divide by 4, and x equals e to the third divided by 4. And then it says, what is the decimal approximation for this solution? Well, you just type in second e caret 3, enter, divided by 4. Sorry, lost my train of thought there. And that's where you get the 5.02. Yeah? Alright. Solve this logarithmic equation. Be sure, Alright, so it's isolated, so I can roll it, which means the e moves over. So I have the square root of x plus 1 equals e to the second. Alright, and again, they want me to get my answer alone using e and not using a decimal. So to get rid of, I'm trying to get e alone, or x alone, I mean. So I'm going to square both sides. That gives me x plus 1 equals e to the fourth. So now to get x alone, I'm going to minus 1, and I get x equals e to the fourth minus 1. And that's B, or that first part. The second part is, we'll analyze it. So type it in. E caret 4 minus 1 is 53.6. Yeah? 2 decimal places. So it's 53.598. 2 places. That bumps it up to a 10. That bumps it up to a 6. So it's 0.6 up. Okay? Alright, this formula, A equals 24.2 e to the whatever t, models the population of a U.S. state, A, in millions. So A is the population, t years after 2000. What was the population of the state in 2000? Well, if t is t years after 2000, and I'm talking about 2000, then t would be 0, yes? And if I make t 0, that's e to the blah 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 times 0 is 0. E to the first, anything to the 0 degree. Oh no, anything to the 0 degree is 1. So the amount in the beginning was 24.2. Okay, and then it wants to know the population of the state will reach 31.4 million in what year? Well, now they're giving me the final amount of the population. They want to know when will it get to that number. So I make A 31.4 equals 24.2 to the E to the 0.0776 times 2003 is 3 years after 2000, so time is 3. So I gotta isolate. Where's my letter? Oh, I don't know what year. Sorry, I don't know that yet. So x is or t is what I'm looking for. So I gotta isolate to drop it. So I'm gonna divide by 24.2. So 31.4 divided by 24.2. You get 1.297520661 equals 0.0, what equals e to the 0.0776t. Alright, so now to solve it for t, I'm going to ln both sides. If I ln that answer, I get 0.260455259 equals, that cancels, 0.0776t. So to get t alone, I'm going to divide by 0.0776, and time equals 34.27. Something's wrong. .4 divided by 24.2. Yeah. Hold on, I'm checking my work, seeing where I figure screwed up here. Okay, that's 1 point, yeah. So if I natural log that answer, I get that. Oh, I did too many zeros. Watch your typing in your fingers. 0.0776. I put 2 zeros instead of 2 sevens. There we go. So you get t equals 3.356, yada, yada, yada. To the nearest year, the 3 wouldn't bump it up, so 3 years after 2000 would be 2003. Alright, complete the table for a savings account subject to 4 compoundings yearly. Alright, so we have this formula. So the amount invested, we're looking for the amount we accumulate, right? No, we're looking for time. Amount invested is P. Number of compounding periods is N. This is R. This is A. And this is T. So if we plug those in, I have 24,000 equals 13,000, parentheses, 1 plus, my rate is 0.045, over N is 4, to the 4 times, I don't know. That's what we're looking for. So if I do inside parentheses first, 1 plus 0.045 divided by 4, I get 1.01125 to the 4t equals 24,000. Okay, now I'm going to start isolating so that I can get t out of the air. So I'm going to divide by 13,000. And 24,000. Take away 13,000 is 11,000. Not take away, I'm dividing 10,000. Oh, I'm tired. 24,000 divided by 13,000. There you go. 1.846153846 equals 1.01125 to the 4t. Alright, so if I want to get it out of the air, you can either log both sides or ln both sides. I'm going to log just because I'm tired of ln'ing. So if I log that answer, I get 0.26626788894. And if I can drop this like it's hot, so that would be 4t times log of, I can just type that in, log of 1.01125. I get 0.004858536. So to get t alone, I'm going to divide by 4 times 0.004858536. Divide by 4 times 0.004858534. Those cancel. I get 4t equals 0.26626788894 divided by parentheses 4 times 0.004858534, and I get 30. Oh, I divided by 4t. Yeah, so that would just leave t. The 4 cancels also. So t equals 13.701 something something, and if you round to 1 decimal place, that'd be the 13.7. Okay. All right, we're filling this one. This one we're using a PERT. Amount invested is P. That's R. That's A, and that's T. So I'm going to take 12,000 equals 6,000 e to the 0.11 times t. So isolate and natural log. I'm going to divide by 6,000. That gives me 2 equals e to the 0.11t. Right? 12,000 divided by 6,000 is 2. Alright, so now to drop it like it's hot, I'm going to ln both sides. So if I take ln of 2, I get 0.693147186. ln base e of e cancels, and I'm left with 11t. Divide by 11, and t equals 0.063. What did I do now? I'm not dividing by 11, I'm dividing by 0.11. Sorry. 0.69314471806 divided by 0.11. There's my 6.3. 6.301 blah 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 to the nearest tenth would be approximately 6.3 years. Alright. Here's a function that models the percentage, p of x, of students who could recall the important features of a classroom lecture as a function of time, where x represents the number of days that have elapsed since the lecture was given. The figure shows the graph of the function. After how many days do only half of the students recall the important features of the classroom lecture? Let p of x equals 50 and solve for x. Locate the point on the graph that conveys this information. After how many days do only half? Oh, okay, so that's why they're changing x to 50. How many ever kids there are, okay, only half of the students. I'm not really sure where they're getting 50 from, unless they're doing like 50%. But x, oh, I get it. P of x is the percent of students, okay, that recall the important features of a classroom lecture as a function of time. So x is time, and p of x is the amount of kids that recall the information. And so they're saying if only half of the kids, and p of x is a percentage, they're saying how long is it going to take for only 50% of the kids to remember? So we let p of x, this side, equal 50, equals 95 minus 30 log base 2 of x. I've got to get x alone. So the first thing I'm going to do is subtract 95, which gives me negative 45 equals negative 30 times log base 2 of x. Divide by negative 30. Negative 45 divided by negative 30 will be 1.5. So log base 2 of x equals 1.5. Roll the log over. So roll the log, the 2 squirts over. I have 2 to the 1.5 equals x. Type that in, 2 caret 1.5, and you get x equals 2.828427125. Round to 1 decimal place, so the 2 won't bump it up, and that's where they got the 2.8 days. Then it says, locate the point on the graph that conveys this information. Well, if I go to 2.8, 50, right there. Yeah? And that ordered pair would be 2.8, 50. Is alright, so it's about 3 days. Alright, complete the table shown at the right to the right for the population growth model of a certain country. The projected 2020 population is blank millions. Alright, well, we are going to use the final population is the initial population, e to that growth rate times time. So it gives me it gives me the population now. This would be my a sub naught. My a is what they're looking for, and there's my k. right? And we need a time. Well, let's see. Time starts at 2006, right? And so if we're doing 2020, that's how many years past 2006? 14 years. So T would be 14. So if I plug all that in, I don't know A. The initial amount was 129.9. E, so my growth rate is 0.0134 times T, which is 14. So if I type that in, 129.9, second divide for E, caret, parentheses, 0.0134 times 14. And I get 156.7049791. It says one decimal place. The 0 won't bother it. So 156.7 mil. Alright. Complete the table shown to the right for the population growth model of a certain country. Again, we're using the final is the initial e to the k times t. So this time they said they gave me the population in millions for now, or for 2006, the starting point. So that's my A sub naught. This is my projected population when I use my model. Okay, so that is your A. They want me to find K, and time. Time is going to be the difference between 2023 and 2006. 2023, 2006 is 17 years. So T would be 17. So if I plug in what I know, this will be going down. Because it's negative. What am I doing? 48.5 equals 56.2 times, or not times, to the 17k. And I'm trying to figure out what k is. Alright, so I've got to get it out of the air, so I'm going to log both sides, or you could natural log both sides. Okay, that's going to give me log of 48.5, which is 1.685741739, equals 17k times log 56.2. Okay, so now to get at k alone, I'm going to divide by 17 log 56.2. 17 log 56.2, but be careful. Okay, you're going to have to put this bottom in an extra set of parentheses because you're doing an operation down there. So, if I take the 1.6857 blah 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 divided by parentheses 17 times log, it'll open parentheses, 56.2, close it, and yeah. No. $2023 minus 2006, that's 17. So we have 48.5, 56.2, e to the 17k. Let me not do this yet. Log 48.5. Let me just do this one at a time. Let me divide by log of 56.2. So let's see, if I do log 48.5 divided by log 56.2, I get 0.963426195 equals negative 17k. Divide by negative 17. Why is that negative? It's not negative, it's an equal sign. So now divide by 17. What am I doing wrong? .5 56.2 E Hold on, I'm gonna pause and see if I can't figure out where I messed up. So I'm sitting here listening to me think. Okay. I don't know what I was thinking. We're using base E, and I just forgot to write the E, which is why nothing would work out. I apologize very badly. Alright, so again, we have, this would be my A sub naught, this would be my A. We're looking for K, and T would be 17 years because 2023 minus 2006 is 17 years. Let's try this again. So I would have the 48.5 equals the 56.2 E, which is what I forgot last time, to the K, which we don't know, T, which is 17K. Alright, so the first thing I'm going to do is isolate E, so I'm going to divide by 56.2. So 48.5 divided by 56.2, I get 0.8629893238 equals E to the 17K. Now, because of base E, I'm going to natural log, not common log. If I ln that answer, I get negative 0.147352959 equals, those cancel, and I get 17K. Divide by 17, and K equals a negative. There we go, 0.008667, blah, blah, blah. 4 places, 1, 2, 3, 4. That's 6, bumps that up to a 7. I apologize, I should not do recordings at 5 o'clock in the morning. Alright, 36. An artifact originally had 16 grams of carbon-14 present. The decay model, A equals 16e to the negative 0.000121 t, describes the amount of carbon-14 present after t years. Use the model to determine how many grams of carbon-14 will be present in 8,112 years. So they're giving me t. So the amount that will be left is 16e to the negative 0.000121 times 8,112 years. Alright, 8,000. It's crazy. Let's type it. 16e caret parentheses negative 0.000121 times 8112, close your parentheses, and you get 5.995665085, and they want the nearest whole number. 9 bumps it up to 6. Okay, so after 8,000 years, there will be 6 grams left. 8,000 years to decay 10 grams of stuff. It's crazy. Alright, the half-life of a radioactive element, whatever that is 10 seconds. If 48 grams of that stuff is initially present, how many grams are present after 10 seconds, 20 seconds, 30 seconds, 40 seconds, and 50 seconds? All right, so where's my little formula? All day. All right, so I have A equals A sub naught e to the kt. I do believe. Let me back up one and make sure. Yeah. Okay. So my problem, where did I go? Okay, my problem is we've got a half-life of 10 seconds. So I have to figure out my decay rate. So again, we can pick any starting point, but let's say that I started with 1 gram. Well, half-life, that would make this 0.5. And that will be e to the, I don't know what k is, that's what I'm trying to find, but the half-life is 10 seconds. Okay, so if I solve this now, I'm going to have to, I don't need to divide by 1. So I'm going to ln both sides. I hope I'm not screwing this one up too. So I have ln of 0.5, which is negative 0.6931471806 equals, these cancel, 10k, divide by 10, divide by 10, and my decay rate is negative 0.069314711806. Okay, so there's my decay rate. So now I can change my time. My formula is going to be the amount left is the original amount e to the negative 0.069, let's call it t. So, here we go. So it says if 48 grams of unibolt are initially present. I was going to say we have too many unknowns. So we have 48 grams initially present. All right. How much is going to be left after 10 seconds? So they want me to change t to 10. So 48e to the negative 0.069 times 10. So type it 48e caret parentheses negative 0.069 times 10, and I get 24.0756, and to the nearest gram would be 24. I'm going to do the same thing and change time to 20, but again, if the half-life is every 10 seconds, I'm increasing by 10 seconds. So instead of doing the math 1, 2, 3, 4, 5 times, every 10 seconds, which is what my time's going to, this is cutting itself in half. So half of 24 is 12, half of 12 is 6, half of 6 is 3, half of 3 is 1.5. I mean, you can do the math 5 times if you want to, but they're talking about half-life. All right, 38. Prehistoric cave paintings were discovered in a cave in France. The paint contained 23% of the original carbon-14. Use the exponential decay model for carbon-14. A equals A sub naught e to the negative 0.000121 t to estimate the age of the paintings. All right, well, what it says is that only 23% of its carbon-14 is left. So if there was 100% to begin with, there's only 23% of it left. And they want to know how long that'll take. Okay? So I've got to isolate. I'm going to divide by 100. That gives me 0.23 equals e to the negative 0.000121 t. Then I'm going to ln both sides. ln 0.23, I get negative 1.46967597 equals negative 0.000121 t, because these cancel. So now to get t alone, I'm going to divide by negative 0.000121, negative 0.000121, and t equals .0001214, and they want to the nearest integer. The 0 won't bump it up, so 12,146 years old. Okay. Alright, complete the table shown to the right for the half-life of a certain radioactive substance. Well, we've got the decay rate, okay? So if we use this, again, half-life, you're saying when is half of the original amount, and I just picked 1, that would be a half left, e to the negative 0.024 t. Alright? When will there be half of the, you could pick anything. You could do 10 and 5, you could do 300 and 150, you could do 50 and 25, whatever. But it's always going to come out to 0.5 on the other side anyway. Alright, I could divide by 1, but I don't need to. So to get t out of the air, I'm going to ln both sides. Alright, and if I ln 0.5, I get negative 0.693147186. Equals, those cancel, and I get negative 0.024t. Divide by negative 0.024, and t equals, divided by negative 0.024, 28.8811, yada yada, to 1 decimal place. That 8 would bump it up to a 9. Okay? Complete the table shown. Now they give me the half-life, and they want me to figure out the decay rate. So same thing. When will there be half of the original amount left? E to the k times t, which is 2455. Okay, so again, I'm going to ln both sides. There's my negative 0.693147186 again. Equals, those cancel, and I get 2455k. So now to get k alone, I'm going to divide by 2455. And k equals, divided by 2455. It says negative 2.8234 e negative 4. What that means is the decimal is actually 4 places left. 1, 2, 3, 4. Which makes negative 0.000282. There's my decay rate. Okay, in 1964, paleontologists discovered the bones of a new species of dinosaur. The age of the dinosaur is estimated using potassium-40 dating of rocks surrounding the bones. Analysis of these rocks indicated that 78.6 of the original amount of the potassium-40 was still present. The decay model for potassium-40 is A equals A sub naught e to the negative 0.52912 t, where t is in billions of years, and it says let A equal 0.786 times A sub naught in this decay model and estimate the age of the bones of the dinosaur. I don't know why they got to go through all that stuff. Okay, they're saying that 78.6% is left out of 100%, obviously, e to the negative 0.52912 t. Alright, so we are going to divide by 100, and I get 0.786 equals e to the negative 0.52912 t. So to get it out of the air, I'm going to have to natural log both sides. So ln of 0.786 is negative 0.2407984866 equals, those cancel, negative 0.52912 t. So to get t alone, I'm going to divide by negative 0.52912. And t equals, divided by negative 0.52912, and you get 0.45509, yada yada yada. 4 decimal places, 1, 2, 3, 4. The 9 bumps it up to a 1. Okay, so they're almost 500 million years old. Almost. Okay. And a bird species in danger of extinction has a population that is decreasing exponentially. 6 years ago, the population was at 1,600, and today only 1,000 of the birds are alive. Once the population drops below 300, the situation will be irreversible. When will this happen? So they're telling me that 6 years ago, the population was at 1,600, and now it's only at 1,000. So the initial amount was 1,600 and the final amount was 1,000, or they want to know when it's going to get down to 300. Oh, no. Today only 1,000, but they want to know when is it going to go below 300. So they want to know when will the final amount be 300. Tricky buggers, they gave us extra information. And that will be e to the kt. Oh, buggers got me twice. Okay, they didn't give me the k. So if I try and solve the problem right now, I have 2 I don't knows, and that's not going to work. And that's why they told me this, so that I can get the decay rate. So the first thing I have to do is say, all right, there's only 1,000 left today from originally 1,600, e to the k t. Now that was 6 years ago, so that would be 6. Okay, so now I can find k, so I'm going to divide by 1,600. I got 1,000 divided by 1,600, and get 0.625 equals e to the 6k. ln both sides. So ln 0.625, I get negative 0.4700036292 equals, cancels out, 6k, divide by 6, and k equals a negative 0.07833339382. So now I can replace that over here with negative 0.078. And now I can solve it for t. So divide by 1,600. 300 divided by 1,600. I get 0.1875 equals e to the negative 0.078t. So now I'm going to ln both sides. And if I take the natural log of 0.1875, I get negative 1.6739766434 equals negative 0.078t, because those cancel. Divide by negative 0.078, divide by negative 0.078, and I get, divided by negative 0.078, and I get 21.5 years. What did I do wrong? Probably rounding. Mm-hmm. 1,600, now 1,000, 6 years ago. 1,600. 0.625, natural log, divided by 6. Alright, so if I do ln of give me a second, so sorry, trying to figure out where I screwed up here. 300 divided by 1,600, 0.1875, divided by negative 0.078339382. I still get 21 point something years. don't like it when I don't get the right answer. Oops. Sometimes you just got to start over. All right. There's a population that is decreasing exponentially. 6 years ago, the population, so the initial population was 1,600. And right now, it's at 1,000 e to the k times 6 years. So divide by 1,600. You get 1,000 divided by 1,600. 0.625 equals e to the 6k. To get k out of the air, I'm going to ln both sides. So if I ln 0.625, I get negative 0.4700036,292 equals 6k. Divide by 6, and my decay rate is negative 0.0783339,382. So my formula would be the final amount is the original amount, e to the negative 0.078 yada 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 t. And I want to know, when will the population drop below 300? So I want to know when the final amount of birds is 300 from 1,600 at this decay rate. Oh, I know where I screwed up. Oh, silly Tamsin. All right. So we're going to get the same answer. We didn't do anything wrong mathematically. 1,600, so 300 divided by 1,600, you get 0.1875 equals e to the negative 0.078t. ln both sides. So if I ln 0.1875, I get negative 1.673976434 equals negative 0.078t. Divide by negative 0.078, divide by negative 0.078, and t equals 21 again. 21, if I round to the nearest year, 21 years. So why are they saying 16 years? Well, duh, because I said, okay, I took the thing at 6 years ago. Okay, so if I take away, well, if I would have rounded right, this would have been closer to 22. So if I take those 6 years off where it went down to 1,000, in other words, I should have put this as 1,000 because now is what that population is. So this should have been 1,000 instead of 1,600. Or you can think about, it'll take 22 years from this point, from when it was 1,600. So from this point, which was 6 years later, it's only going to take 16 more years. So if I take away that 6 years from the beginning, there's my 16 years. Okay, so you don't screw it up as bad as I did. Just remember, this isn't necessarily the initial, okay, population. Look at your words. And today, so here's my initial population. This should have been 1,000, not 1,600, and everything would have worked out fine and dandy. All right, so That is the last question. We are done. Happy homeworking. Practice, 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 and good luck on your